Hello. Today we're going to talk about Topic 1, Section 4, Financial Applications. So the graph shown right here is the price of one movie ticket in the U.S. over the last 50 years. Okay, so using this graph, we want to decide what has more buying power. All right, let's see. Let me get my pen. So we're going to do the U.S. dollar and $8 in the year 2000. So that would be roughly here. And then we want to look at the 50 cents in 1940. So that would be right about here. So looking at the different buying power, okay, well, hopefully you're looking and thinking this has more buying power because not only can I buy a movie ticket, but I can buy a little bit more. Okay, so the whole idea here with this lesson is talking about how money changes over time. The value of the dollar changes. Okay, and so we're going to talk about how we can adjust for that with math, of course. So first thing you want to talk about is compound interest. Okay, so when you put money into that account, you get interest. That's going to You will be paid a certain amount every so often, and that's called compound interest. Okay, so here we've got our example. We have 350 Turkish lira in a savings account that offers 2% interest rate compounded annually. Okay, so every year they get a little bit more. Okay, so we want to calculate how much money will be in this account after 4 years. Right? Assuming we're not touching the money. It's just sitting there, just collecting. Okay? So the first year, or after the first year, we would do this. 350 Turkish lira times 1.02. So why 1.02? Well, that represents 100% plus 2%. Okay? Because we're getting a 2% interest. So we're getting the original amount plus a little bit more. Okay? Let me change my pen size. It got a little large there. Okay. So then after 2 years, we would take that amount after the first year and multiply it by another 1.02. Now we have a new amount in our account. Do it again for year 3. And year 4. All right, so here we're giving it to the nearest lira. Okay, well, I guess that's not what, well, we would change our cents. Okay, but this is how we would calculate our amount after each year. So let's look at our pattern. Okay, what I've got is I could take 357, okay, so after 2 years, I could take 357 times 1.02. Well, think about what that 357 was. That was just 350 times 1.02. So can I rewrite this as 350 times 2 of those 1.02s? Okay, because we're replacing that. Okay, so 350 times 1.02 is replacing this 357, and we're going to multiply that by 1.02. And that's how we get this. Well, I can do it again. I can take this amount, that 364.14, and I can rewrite it as this. So now I have 350 times 3 of these 1.02s. And then I can do it again. All right, so what we get here is a geometric series. Okay, and that's the whole thing you wanted to see here. That's the relationship founded here. Okay, so that's how you get one after another. Of course, there's a formula for that. Oops, that's my phone, sorry. So what we have is a formula. Okay, and this of course is going to be on your IB booklet. Okay, so you want to know what this is. The biggest thing I can say about this formula is notice that PV it doesn't mean a variable times another variable. That's not what this is. PV is a whole thing. It represents the current present value. So this is one thing. It's not one thing times another variable. Okay? PV is just one thing, just like FV is its own thing. Okay, so let me show you what that means. All right, so here we're going to do our first problem. So we want to calculate the amount of money in an account where 500, what is that, euro, is invested at a nominal rate of 3.4% for 10 years. So we want to know what happens at the end. So we're trying to find the current face value. So the future value. Future value. PV is the present value. Okay, so we're going to do 500, all right, times, then we're going to do 1 plus, the rate is 3.4 over 100 times K, and K is, let's see here, we don't have, this is happening every year annually, so K is just going to be 1. So then here, K times N, where N is the number of years, we have 10. So we just plug this into our calculator. All right, we've got 3.4 divided by 100 plus 1. Okay, I just want to make sure you guys are doing this the same way. So it should be 1.034 to the 10th times 500. Okay, so that will be 698.51 euro. Oh, I think that's euro. Okay, let's do another one. So Joe invested this amount at an unknown interest rate that is compounded annually. At the end of 10 years, this investment amounts to $5,400 blah 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 dollars. Find the interest rate at which this money was invested. So we know that the future value was 5409.67. The current value is, the initial value was 2,750. All right, then we're going to multiply that by 1 plus. We don't know what the rate is. And then we're going to do 100 times 1, 1 times 10. Okay. So let's see, I'm going to go ahead and divide that. So 5409.67 divided by 2750. All right, so I get a really long number. I want to keep that number, that 1.96715.273, blah, blah, blah. Okay, equals 1 plus R over 100 to the 10th. Okay, so then using this answer, okay, so that previous answer, I would plug this into my calculator. I want to remove this 10, right? Order of operations, right? So we're going to remove the exponent. Let's see. So to remove the 10, we would take the 10th root. And that's what we're going to do to eliminate that. Okay. So here we take the 10th root of that number. Okay. So just in case you don't know how to do this on your calculator, all right, notice the last thing I typed in was that division. So I want to do the 10th root. Well, there's not a button on my calculator, so I have to go in and find it. I have to go to Math, and then I'm going to go down here to, it's number 5. It's the X as the index. Oh, I went too far. X is an index of that square root. So I want to enter. And now I can put 10 as the index. And then there I can put my answer. Now how I put my answer is I do second and then the negative sign down here, my answer from before. So then I hit enter. Okay, so now I've got that long number. So 1.07 da, 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 equals 1 plus r over 100. So now I would just complete that out. All right, so I would take my answer and I'd subtract 1. All right, then I take my answer and I had to get rid of that 100. I would multiply by 100. And now I get 7.00000, right? So it looks like my interest rate was about 7%. Okay, so my interest rate ended out to be about 7 point, technically I don't want to put all those zeros, I'm going to leave it like this, 7%. Okay. All right. Next slide. Okay, so let's do it again. Calculate the amount of money, I'm sorry, the amount of interest earned when you have, Russian rubles are invested for 9 years at a nominal rate of 5.3%. So we want to okay, so our present value, sorry, I was just making sure I knew what we were solving for. We want to know how much interest was earned. So we'll get to exactly what that means. Let's plug in what we know. We know that we initially put in 1,000. We know that the rate was 5.3. It was annually, so K is just 1, and N is 9. Okay, so let's see. I'm going to go ahead and plug that into my calculator. I'm going to clear out everything. So first things first, 5.3 divided by 100. I could have just moved the decimal. That's okay. So we're going to take 1.053, because I got to add that 1 over here, and raise that to, so I'm going to use this caret button right there, raise it to the 9th, and then multiply by 1,000. All right, so that means FV, all right, our future value was 1591.68. 1591.68. But of course, we wanted to know how much interest was earned. Well, they didn't earn this much money. That's how much they got in the end. So what they earned, okay, is your future value minus your present value is what you earn. Well, hopefully you earn and don't lose, right? You don't want that to be a negative value. All right, so here we do 1591.68 minus our present value. So we earned about 591.68 Russian rubles. All right. Okay, so inflation. Sometimes when you invest money, your investment grows over time. But this does not mean that your actual wealth increases because the amount of money grows in a bank. Okay? Of course, your bank does not take inflation into account. Okay, what I mean by inflation. So let's say I buy a painting today. It's worth $100. And next week it goes, in 10 years it goes up and then it's worth $1,000. Okay, that sounds like it went up. That's great. But what if the US dollar isn't worth as much? And now that $1,000 painting isn't, I guess that would more be like a depreciation of value. Okay. That's basically what I'm trying to get at, is that the cost of the dollar may change. Okay. So yes, you're going to get more money, but we're hoping that it goes in fluctuation with the economy and the what a dollar can buy you. Okay, like we saw on that first screen. Okay, about the movie tickets. Okay, So you always have to incorporate an inflation rate into it if you want to talk about the real value, the buying power of an investment. Okay, just want to understand the wording there. Okay, so Simone invests $12,000 for 20 years, pays this compounded annually. The annual inflation rate over time period is 3.8%. So we want to calculate the real value of the investment after 20 years. This, you know what to do. Okay, Simone put in 12,000. Yeah, I'm a teacher. I don't have 12,000. So, so then we do 1 plus, I don't know, what are we finding? Okay, the compounded interest was 4.2% over 100, and this was annually, so K is 1, and then N is 20. Okay, so plug that into your calculator. Okay, so your interest rate, your interest rate multiplies your initial value. That's what gets your value to increase. That's how much you're gaining every year. Okay, that's what interest rate does. It multiplies. Inflation is how it's affecting the worth of your dollar. So inflation is going to have to be division. Okay, so interest rate is multiplication. Inflation is by division. So what we're going to do is we're going to take that amount we got before, so our 27,323.46, that's the rounded, but you can use the calculator to get a more accurate answer. And then we're going to divide it by the inflation. So here, the inflation would be, well, again, 3.8%. So remember, that's 100% plus 3.8. So you write this as 103.8%. Okay? Percent. Now, as a number, as a decimal, we would move the decimal to the left twice and get 1.038. So that's what we're dividing by. And we're going to divide by 1.038 for every year we are investing. So we're going to divide by that 20 times. Okay, so I'm going to go ahead and put that in my calculator. I'm going to take my previous answer and divide it by 1.038 to the 20th. Okay, so realize that's only raising the 1.038 to the 20. If I'm ever unsure, I can always add parentheses. Nope, too far. Let's see, second insert parentheses. All right, so we get 12,959. 12,959.51, I believe. Yes. Okay, so that's what it's not congruent. What am I doing? Not geometry. Not yet. Okay, so that is what it equates to. Okay, just to clarify some vocab, because I think I said this wrong earlier. I said real value. This isn't this value right here is your nominal value. Remember, your nominal interest rate. Okay, so that's how much you would gain over 20 years. Okay, to find the real value, that's this answer. Okay, so what the real value means is, okay, I have about $12,000 now. In 20 years, I'll have this much, which looks like a lot more, but that's about what 12,900 is worth today. Okay, so yes, my amount grows, but the dollar value changes as well. Does that make sense? Okay, let me know if it doesn't in class. So compound periods. All right, you can do it you could do it yearly, quarterly, or monthly, okay, or cut it in half. So we can change that value with K. So remember I said it was once a year, so K is 1. All right, we can change it if it happens half yearly. Okay, that's weird. Usually half yearly. Usually I hear that as more semi-annually. Anyway, so quarterly, monthly, things like that. So let's do an example. Okay, so here we're going to determine the value. Remember, we do have our formula. Okay, now we're going to do half yearly, quarterly, and monthly. So we're going to plug in initially 2,750 times 1 plus our rate, which is 4.5 over 100, and this is half yearly, so this is twice a year, and then we do 2 times 4. All right, for quarterly, we would do the same thing, but now we would just write it as, instead of a 2, it's quarters, so 4 quarters in a dollar, so 100 times 4. And then we would do 4 times 4. Okay, hopefully this is making a little sense on how we plug things in. When we talk about monthly, again, remember we're talking about the year, so there are 12 months in a year. Yeah, that's a good thing to know. All right, let me see. Okay, there we go. I've written it all out. Okay, so here we can work it out, or we can do it on our calculator. Isn't that great? Calculators are wonderful. Okay, so now that I brought the calculator up, we can go to, let's see, I think it's under math. Nope, I lied. It's under apps. So apps, or applications, we're going to hit 1 for finance. Okay, if you don't have it, then you can just do it algebraically by plugging it into your calculator. Let's see. So we go to TV M solver, and then now we can plug in our values. So let's see. I like this because it's written out specifically. So N is the number of times total. So 4 years, 4 times each year. So that's going to be 16 for the first one. Okay. Then okay, sorry, I got confused there. This is the part, it's starting with quarterly. Okay, so we go here, 16 times for quarterly, 4.5 interest rate. We are losing 2,750 because that's how much we have to put into the bank. Okay, so then our future value, we don't know what it is, so leave that 0. We're going to say this is P over Y is the number of payments a year, and C over Y is compounding periods in a year. Okay, so we want to know what the future value is, FV, so I'm going to highlight it and I want to solve it. So how we solve it is we want to do this green button at the bottom of our calculator. So we're going to do alpha and then enter. And notice that changed what my future value is. It's solved for the future value. Okay. Okay, so here I've changed the screen to do it, what do they call it? Half yearly. I don't know why I can't remember that. Okay, so half yearly would be 8 times in this case, 4 years, twice a year. All right, and then I changed these numbers to 2. So then I want to solve it. So alpha solve. And here we get about 3,286. So 3,286 roughly. Okay, hopefully this is making sense. So then here we can change it again for our monthly. So what is that? 12 times 4, so 48 times. So we want to solve for this. So I'm going to do alpha, enter. So now we get 3291 roughly. 3291. Okay, which makes sense. If you do a little bit more or happens more often, you should make a little bit more. Okay, albeit not much more, but it's still more. Okay, so here we want to invest and we want to, let's see, monthly, find the minimum number of years that it will take for your investment to double. Okay, so if we want our investment to double, so that means we want to earn 4,600. We get the initial value was 2,300. Our rate is 2.4, and it's compounded monthly, so this is going to be 12. We want to figure out what n has to be. So we could solve this, but that requires us to use logs, and I'm not sure how many of us remember that, because I can tell you when I teach it in Algebra 2, most of the time it's people's least favorite. So what would I suggest to do? Having your calculator. Okay, so plugging in these values into that same application in that last slide, you should get this, right? All right, but this time what you're solving for is the number of times a year. Okay, so again, we pull up our calculator and we plug in these values. N is the only thing we don't know, because we don't know how many years. So we're going to do alpha solve for n, and we get 346.92. Okay, so remember, we want to find, let's see, the minimum number of years that it will take for our investment to double. Okay, so that's how many total times it's going to happen. Okay, but remember, we want to find just the number of years. Well, this represents the number of years times how many times a year, so times 12. So we need to divide this by 12. Okay, when we do that, I don't remember the number. Oh, so what is that? 346.92 divided by 12, we get 28.91. So really n is 28, that's a terrible, 8.91, which means I can't do it in 28 years. Okay, so I need to go up. We want to the nearest year. So for me to make sure that I hit my mark, I need to make sure I go to year 29. So it's going to take 29 years. Okay. If you don't have that, I can show you, or you don't have that application, you can do it by logs. So you get, this is 4,600 over 2,300 equals 1 plus 2.4, what is that, 1,200 to 12n. So then to get rid of this base, okay, that's the base, that's the 12n is the exponent. To move that base, we move it into log form. So it's going to be log base of this gross number of, all right, so the argument here would be 4,600 over 2,300 equals 12n. So then you would get this answer on your calculator and divide it by 12. Okay, and since you guys like it when I show you this stuff, I'm going to show you the log. So we want to change the base, so I'm going to go to math, and where is it? Okay, so it's math, it's all the way down here, it's under A for me, so we want to go to log base, hit enter. we can write in our base as 1 plus 2.4 divided by 1200. Just write it in as an expression. Calculator's smart, it'll figure it out. So then in my argument, I'm going to write 4600 divided by 2300, and then I'm going to hit enter. And I'm going to divide that answer by 12. I got the same exact thing. So you can do it with logs if you remember that way. Okay? Either way will work. Okay, so depreciation. So when things lose value over time. Okay. My husband buys a brand new car, loves it. But guess what happens right when you leave a parking lot? That's right. It's now worth less because now it's pre-owned. Okay? Cars depreciate. Yes, we can talk about fancy vintage cars, but we're not. Okay? We're talking about you and me here. Well, at least me. All right? So my iPhone is going to depreciate in value. Most technology depreciates in value. Okay? Hopefully there are things that will appreciate over time, such as artwork. I know is famous because usually the artist is penniless until they die. That's really sad. Sorry, that took a turn. Some things increase in value. Jewelry. Well, no, not all jewelry. Well, you get the idea. Okay. So here, you just need to remember that when you depreciate, R changes. It's now decreasing, so R is now negative. So make sure you take note of that. Okay, so let's see what I was talking about there. So let's start with the future value. So there we go. Now I got my pen working. Okay. So our future value is just our present value. So 450 times 1 plus our rate. Wait, hold on. Depreciate. What did I say about depreciation? Make that a negative. There we go. So depreciation means this is a negative. 15% per year. So once a year and n number of years. Okay, so let's calculate the price after 4 years. All right, so that's going to be 450, 1 minus 15 over 100 to the 4th power. So we type it into our calculator, 450 times 1 minus 15 over 100. I still don't know why I don't just move the decimal, but whatever. So we've rounded to the nearest cent, gets us 234.90. So 234.90. I don't know why I wrote it there. 234.90. All right. So now we can find the price of the washing machine after 100 years and comment on the results. So let's look at that. So for 1 minus 15 over 100, I'm just showing my work. This is what I'm going to do on the calculator, so this is how I'm showing my work when I plug things into the calculator. No, you're going to ask me that. Okay. Oh, I didn't move my calculator correctly. Okay, so here I'm going to take the same answer, so I'm going to go up and hit enter, and it rewrites the same equation, and then I'm going to delete the last thing I wrote and put 100. And so now, oh my goodness, I get times e to the negative 5. So hopefully you know that means that's times, a scientific notation, so times 10 to the negative 5. So that means make this decimal even smaller, so 3.936. So that's 3.936 times 10 to the negative 5. So we get 1, 2, 3, 4, 5. 936. So what do you think about that? Well, hopefully you thought that makes sense, because think about after 100 years. Do you think that washing machine's still working? Well, I can tell you that the washing machine that my dad used, by the way, he's 74, so he remembers when they first came out with washing machines and getting it for the first time in elementary school. I'm glad I don't have to use that washing machine anymore, right? Every year they're coming up with new and better features, well, at least on my iPhone. Washing machines, it's like every couple years. Okay, I don't know how many other features they can really add at this point, but I certainly expect to see after 100 years that washing machine is worth nothing, and it's in the junkyard. That's what happens to most electronics. Okay, so let's see. Calculate the rate of depreciation for a car that cost this when new and when it's 8 years old. So we know the future value, so it gets less. Started with a lot. And let's see. We want to find the rate. Oh, depreciation. There's that number. There's that word again. I need to make sure I do a subtraction. Okay, we don't know what R is. We want to do, we should have a car that costs, it's 8 years old. So we're just going to do it yearly. So 8 years old would make that 8. All right, you can plug this into your calculator either as this equation or using that fancy program. Either way you solve it, you're going to get this as your answer. Okay, so your rate is going to be this long decimal. If we write it as a percentage, remember you would move that over 2 places, so we would actually get 6.19%. Now, why is it negative? Oh yeah, that fancy word over there, depreciation. Okay, so that means it's decreasing in value at a rate of 6.19%. Okay, so we don't need to write that as our answer. You would say this is your rate of depreciation. Okay? I guess I should circle that as my answer. All right, so that's it for today. This is what you should know. Hopefully this makes sense. If not, you know where to find me.